on. This is your indicator. When you're done, click the little stop block and then hit upload. But you can just let it go right now. You're recording right now.
So I can put pause if I want to.
Correct.
If I want to get angry with one of the students, and
we can edit all that.
Pause it.
So yeah, you can minimize this and go back to your lesson. You minimize that, or yeah, go back to course. And you're recording now. So, what time are you done?
I'll be done in about, I would say, 1 hour or so.
An hour? Okay.
Yeah. 4:05. Okay, for this class I'm going to be using a Blackboard, and of course I'm learning about the Blackboard, so we're going to be doing this stuff in there. My lecture is going to be captured and it's going to be put on the Blackboard, so in case you want to go back and look at these things. So this is the first time I'm doing this, so we're going to figure out how we're going to do it. So first thing first, on the announcement, so of course if you are not on the roster, you are not going to have access on the Blackboard. For those who are on the waiting list, on Monday we can figure out your priority over here, and then if you are part of the class you can go in and sign up, and it's going to get you about a couple of hours to have access on the Blackboard. So starting with the announcement, I have my office hours and the lab hours. So 4058 is designed at 11 to 2:30 on Tuesday. You do not need to go to that one, but you have to have 54 hours of lab for this class, and that's required by the school and above that the state. So we have to show 54 hours of lab for you for each class. That's my schedule right now. That is my lab hours, but we're getting other computer science instructors, so we're going to create a schedule. We're going to post it hopefully by tomorrow on the door of this one and the room 216, and that way you would know when it's going to be available. You can come into any labs. When you come in, you sign in through that station if it works, and then any of us can help you out. Of course, if you are in my class and you come to my lab, that's going to be much better. But if you cannot make it, you can come into one of these labs that we're going to post it over there. We cannot leave you in the classroom with nobody around. So the next option would be D building, that you can go in there and you can use the D building for your lab hours. So I was forced to put your lab some grading for it. So if you don't have 54 hours, then we're going to start deducting points from you. I personally like to do my labs in coffee shop. So whenever I want to write a program, I go to a coffee shop and write my program over there. But that's a requirement to have 54 hours of lab for your class, for this class. So we got to figure out that for you. So if you cannot find any time between this one and Dr. Wilkinson, who was here before me, then you got to go to the D building, and you got to understand in D building there is nobody to help you out. So we are encouraging you to figure out the time here. And if none of this is going to work for you, then I guess we got to figure out what we're going to do. So that is, any questions on this? This is my office hours. So basically I'm here on Mondays, Tuesdays and Wednesdays, the whole day from morning to night. So if I'm not lecturing, you can come and talk to me. Other than that, you can check my office hours and my lab hours. You can come and talk to me anytime. You can talk to other instructors about the issues that you have, and you can go to the D building for any extra hours you want to put. So my information here is on the instructor information. about, I put the office hours over here, the phone number for the office, my email address that you can contact me. Of course, there is a message center here. I have to make a habit of reading the message center here more often, but I definitely read my emails every single day, maybe 2-3 times a day. So if you really want to get hold of me, either call me or send me email. I rather email because I check that more than my voicemail, so I can get back to you. Once again, there is a message center here that we can use it, but I have to make a habit of checking it. Another section would be the syllabus. So if you go to the syllabus, of course you're not seeing all of these things, you only see the first one, the syllabus for this class. So if I open it up, let me, okay, we just lost it. So my email address again, my personal email address, if you want to get hold of me, that case, we have 74 hours of lecture or classroom, 54 hours of lab, which is required for this class. The requirement to come to this class is Math 9. I guess if you didn't have it, you would not be able to register for this class. My office number and the business department in case you need to get hold of me for some reason. This is C++ programming. We have 2 books for this class. One is computer science book. That's going to be this one right here. And then the other one is going to be the C++ book. So for the first few weeks, we're definitely going to put a lot of emphasis on the computer science book. And then we're going to focus on the C++ going forward. Definitely bringing a flash drive is going to help a lot. That way you can save your stuff and take it with you. So we have 45% for the test and quizzes, and maybe I'm going to do some projects for you on that area. And then we got some 25% for the final exam, and then we got assignments for 30%. So a typical rule of the attendance is going to be applied to this. And the last thing is that if you decided that you don't want to continue to the class, you have to drop yourself. Otherwise, you're going to get an F in the class. I mean, I try my best, but it's going to be on your responsibility to go and drop the class. Otherwise, you will get an F for the class. And then we will have our assignments. That is going to be under the assignment section. So the assignments are going to be listed. I'm going to open it up. You're not going to be able to see all of those things. I'm going to create the dates, and you're going to see them. You will see the assignments coming up as soon as I open it up for you. What else do we want to see here? Any questions so far on the things that I talked about so far? No questions? Excuse me, sir. When I'm talking over here, I don't like people talk over there. So either you can take it somewhere else, or mainly it's because of other people cannot hear me very well. So if you have something, you can take it outside or go somewhere else. Okay, for this class, I have chosen to use a compiler called CodeBlocks. CodeBlocks is a compiler that's very light. It is free to use. We might change it to Qt, that the other instructor is using it for mainly graphic stuff. This one is very light. You can download it. It doesn't take that much of a space. You can go to codeblocks.org, or you can just look for it, and you can go downloads. So you can see there are going to be under the binary, we will have 2 downloads. The second one is going to have a extra compiler with it. This is the one we want, with the 74 megabyte. You can just download that one. It is once again very light. It's going to be not taking that much time to do it. And then you can install it. When you install it, there might be one issue with it, because you're downloading 2 things at the same time. So you might have to go to settings, compiler, and you go to the tool chain. In here you can say auto detect. Basically it needs to know where this mean GW32 G++ is. A lot of times it's going to be connected by itself. If you download it and it doesn't work, you go to the tools, you go to the compiler setting, you go to the tool chain, you just click auto detect. It's going to go find it for you. So if you download the compiler, it doesn't work, that's where it is going to be. So when you do that, you're going to start with the create a new project, and we're going to be working with the console application for this class. So when you click on that one, we're going to choose a C++, and then you can tell what is the file or the project name that you want to use, and of course the directory that you want to use. You can change it to anywhere you want. Of course in this computer, because it's protected, I'm not sure where you can put it, so you say next and then finish. So if it complain about the directory you're using, you don't have the permission for it, you got to go find another directory. Maybe you can say create a directory on the desktop with your name and put everything in there for now till you figure out with your flash drive and all those things. So this main is going to come up. We can create a template for main. We're going to play with that later on. So when it comes up, it's going to have some stuff for you, and we're going to go over all these things later on. So that's going to be just a template that's going to come up. So I can go to the build, I can build it, I can run it, or I can build and run at the same time. So if I build, if there is no issue over here, it's going to bring me a console, and it's going to say something in there that I was asking for it to do. When we go over the assignments, we go over, see what's going on. Any questions on the compiler? Okay, so I'm going to go over the first chapter, that is chapter 1, and then we're going to have some assignment on this one, and then we move along. I'm going to alternate between this book and the other book for now. So today we're going to work with this book, and on Monday I'm going to switch to the other book. So in case you don't want to bring both books with you, that's the way it's going to be. If you want to buy a used book, I don't have no problem with it. I technically think that there are lots of material online for you to figure it out, but my tests and my assignments are from this book. So if you buy a used book, it's going to be your responsibility to figure out what is the difference between that book and this book, and if the assignments are not the same, then you have to figure out a way to do the assignment. The assignment that you submit are going to be based on this book. So if your book that you're buying doesn't have this assignment, then you have to copy it from somebody or write it down or whatever you want to do. It is going to be your responsibility. It's not going to be mine. I think you can do it, but you have to take charge on it. Don't come and tell me you assign problem number 18, my book doesn't have 18. I'm not going to do anything about it. And if the 18 says something and your 18 says something else, I'm not going to take it. So remember, if you're buying a used book or you are getting online or some other versions which is doable, you have to be sure the assignments and the things on this book is covered the same thing on the other book. Okay, so we are starting with the chapter 1. That is going to be the introduction to computers and C++ programming. So we start with that one. The very first thing is that the processor is CPU we are talking to the main memory only. The CPU doesn't care what else do we have on the computer. The CPU only going to need the stuff or look at the things on the main memory. So for the programs to work, we have to bring it down to the main memory somehow. Definitely no program fits in main memory, so we're going to bring it in pieces, in chunks, and then we're going to swap it. We're going to look at those things on the other book, how is the basics of those things going to work. So if the program is on the memory, we're going to have some kind of an input and output. The input, usually right now the standard input is a keyboard. So if my program is asking for something, it's going to sit over there for me to, or the user, to enter it from the keyboard. And of course other devices of the input can be the mouse or joystick or whatever it is, or the input devices. And the output device, the standard output device, is the monitor. And then later on we're going to learn to read from a file and write to a file or do things like that later on. Secondary memory is some other storage that the CPU is not looking at. So my hard drive would be the secondary memory, my flash drive, CD drive, any kind of a storage place that we are saving the stuff on it on the hard drive is called secondary memory. The reason it's called secondary because it's not main memory. CPU is going to be looking at the main menu, main memory, and that is the primary one. That's the first one that's going to see. Everything else is secondary. So when we have this stuff on the memory, we're going to be looking at it at the 1 byte at a time. 1 byte is 8 bits. Remember, the computer only understands the zeros and ones. The computer CPU does not understand anything else beside the 0 and 1. 0 and 1 from the electricity point of view is either has electricity or doesn't have electricity. So it's just like a light switch, on or off. Of course, Dr. Wilkerson is teaching logic design that you can go through details of those things. That's very interesting. Of course, if you are going to computer engineering or electrical engineering, you're going to learn a lot more about those things. We're going to talk briefly about it in this class anyway. If you have any questions during these things, just raise your hand or say something so we can stop and talk about it. So your program is going to be talking to the computer, and of course along with your program there is going to be some data that's coming in, and the computer is going to produce some kind of a output. So every time we're talking about anything, it's going to be the input and the processing and the output. We call it IPO, input, processing, output. So the compiler is going to come and look at the program. So we're going to write a C++ program in an editor. You can technically write it in Notepad. You can write it in Microsoft Word and save it as a text. So it's just a text editor. The reason that we're choosing a different compiler or different editor or IDE, whatever you're going to call it, is how is that going to help me to look at my program. Some of them, like this one, is going to highlight the keywords, highlight some of the things. It's going to be easier to type in. So that's going to be the difference between those things. So when I'm using any kind of a compiler, of a C++ compiler, the very first thing that's going to do is going to look at my code, and it's going to look at the syntax error. Every program has its own grammar. It has its own syntax. So for the compiler to be able to do anything, it has to be sure that my syntax is correct. Otherwise, it cannot make sense. So if my grammar is not correct, then it cannot understand it. It cannot do anything. So if that's the case and it can read it, if it cannot read it, then it's going to display some kind of an error, that there is something wrong, and then we're going to do something about it. Now, if it can read it and everything is readable, it's going to compile and it's going to create machine language. Machine language is going to be a bunch of zeros and ones. Sometimes you go to your hard drive, you open a file, and you see a bunch of weird characters. That can be potentially an executable file, which is a bunch of zeros and ones. We call it binary file, and the computer is trying to make sense out of it, so it brings up some character that doesn't make any sense. But it's a bunch of zeros and ones. And of course, that machine language is going to need the data to process, so the data is going to come along with the machine language. And that's what it makes C++ a little faster than, let's say, Java or other languages, because it's going to have a binary code which is very close to the machine language, and it's going to be running a little faster. The problem with that is if I compile it in one machine, one type of machine, and I want to move it to another platform, I have to go and compile it on the other platform. So let's say I do it on PC, now I want to run it on Linux. That binary code is not going to work. Remember, it's close to the machine, it's not going to work. So I have to take my program on the Linux and compile it on Linux for it to work in Linux machine. That's the drawback with the C++, which Java was trying to fix it. So sometimes we have some object code for C++. We learn a little bit about objects in this class, and a lot more on the 3A if you're moving to that one. And the object codes are can come in through my program, or it can come in from other places. So when you compile, you can see at the end of your compiling that you have some file called obj, and those are the object file that's been created from your program, and then you can bring some from outside if you need it, and then you link them together, and then you create a complete machine language. So the idea started that we want to reuse code. If there is some codes out there that's already written, I don't have to rewrite it, I can use it and I just copy it. That is not the same as copying and pasting code for your assignments, right? You're going to write your own code, right? Okay, so algorithm is the way that we're going to define the steps of what we're going to do with our program. So if we call it IPO, input, processing, output, the input is what's coming to the program, the processing is going to be what is it going to be doing, and the output is what's coming out of it. So in this case, number one, it says get the list of names. So where do they come from? For now, it's coming from the keyboard. So we're getting the list of names from a keyboard. Get the name being checked, set a counter to 0, do the following for each name, and announce that answer. So number 5 is the output, number 1 is the input, and the rest of them are the processing that we do in our file. So this is some kind of a design process. We have to start with the problem definition. The biggest problem that we have in industry up to today is that we don't understand the problem, and we go out there and we create wonderful programs. We take it to the customer and they say, this is not what I asked for. There's a lot of lawsuits going on because we don't understand that part. Because if I don't understand the problem, I can create a wonderful program, but it's not doing what they asked for it. So when we figure that out, then we're going to start doing the algorithm design. So we're going to write down the steps that we need to do. I have been trained not to turn on my computer up to that point. So the problem definition and algorithm design is all documentation. It's nothing to do with the coding. Because when I have my computer on, when I'm coding, my concentration is not how to define the problem. My concentration is not how to create the algorithm. My concentration is how to make my code work. So, and that's the major problem that when I was working in industry, I take my programmers to customer site to gather the information about problem definition. And of course, my programmer, including myself, we're going to start thinking about how we're going to write the code for it. As soon as we start thinking about how to write the code, what do? We don't listen to the customer anymore. So we don't listen to the customer. We don't know what the problem is actually. And we're going to go and create something that they're not asking for it. So in real life, what we do is when we define the problem, we're going to go and write a document about it. We're going to send it to the customer and say, this is what we think that you are talking about. Is that correct? And the customer may or may not come back and say, you know what, that is not what I asked for. And then we can redefine it. We can talk about it and do it. I do the same thing after algorithm design. I said, does this sound right to you? This is something you want to do. So if you're working in big companies, they have a few people on the two area on the top. They call them system analysts, or depending on where you are, they have different names. But when we get to the actual coding, we have tons of people doing the coding. So that makes a difference between a programmer and a software engineer who understand the whole process versus I'm just going to be doing coding. So the coding, as far as I have my algorithm, I can give it to a group of people and say, okay, code this in Java. I can take the same algorithm, give it to some people and say, code it in C++. It should not make that much difference because I already have my algorithm done. So when we are going to be coding, I'm going to have, let's say, 100, 150 people are programming. So if there is any issue over there, potentially I can have 150 people sitting around not doing anything because we had some issue on the problem definition. So if I have my problem definition document and I send it to the customer at the beginning, if something goes wrong, maybe only few people are going to be sitting around doing nothing. But if it's going to be on the coding part and we find something wrong with the problem definition and we have to send it to the customer and we have to redefine it and come back, I have 150 programmers sitting around doing nothing. So that shows how important it is to know about the problem definition and the algorithm design before we start doing the coding. Of course, if you have a small projects like what we're doing in the school, it's not going to be that much different because you can do all those things. But we have to practice on those things for the real life. So this is one of the early programs, a sample program that we can go over it and look at it together. And then by Monday, you're going to be writing some of these programs on your own. First thing first, we will have something called pound include. Pound include is going to go to the library when you download your compiler. It's coming out with some library for your compiler. So there are some codes that is going to go and physically put it on top of your program. So when you start compiling, the first thing it's going to do is going to go to that library, it's going to find the IO stream, and it's going to get that block of code and bring it and physically put it on top of your program. The next one, it says using namespace std. When you learn about the objects, when we want to use a certain function, we have to say where this function belongs to. So because I don't want to keep saying that my cout and cin belongs to the std, I just put it under using namespace std. So every time it doesn't know where is this cout belongs to, it looks at this one and says, okay, it's std. So I don't have to put std : cout, std. So if some of you are looking at the program on internet, you might see std : because if I don't use this one, I have to put it right here, all of these lines, I have to put std on it. Now, I have int main, that is my main function. We're going to be writing things in a function. So I start with open braces and braces. The way that I want to do it, so I don't forget about my braces, every time I open one, I close one right away, and I be sure that they're going to match up. This compiler, the code block, does that for you. So whenever you open one, it's going to close it right away, so you can write it in there. For easily to be read easily, everything is indented. So these braces, I can see right away, this is the end of that one. So everything is indented. So if I had another block of code over here, I would indent those too. So you can see each block of code. We work on those a little more. This is how we're going to define our variable or identifier. We're going to go through those things. For now, we have cout, which is the standard output that's going to show on the screen. Cin is a standard input, which is going to be reading from the keyboard. So for this program, what's going to happen is it's going to display this line, it's going to display this line, it's going to stay here waiting for the user to put the number. So as soon as a user puts 10, then it's going to display this line, and it's going to wait over here. The user is going to put the 9, and it's going to display the rest of these lines. Those are the couts. This is the scene. So if you want to look at it in a higher picture, that's the template that we have for our program. On the compiler that you have right now, or any compiler you want to use, they have some kind of a editor template. You can add or deduct anything you want to show it. Later on, we're going to be working on putting some comments on the top of your program. That's going to include your name and your description of what the program is doing. So those are going to come on the top. Sometimes some of those can be repeated. Okay, so this is testing the C++ setup. This is just to be sure that you can compile something on the compiler. So we're going to try that tonight, and that's what we're going to do right now. Before we start doing that, do we have any questions? Anybody has any question? No questions? Okay, so you're going to compile and run this program. It's going to display what? Testing 1, 2, 3, right? So that's what we're doing right now. And then I'm going to put the assignments on the assignment tab. It's going to be open up for you to be able to do it.